That's me. I'm a third-year data science and media art and design student in the college, and this is how I normally start my morning. I get up and I make my cup of espresso, but I have, some gripes with this machine. In order to kind of get it to do what I want, to hit the kind of proper temperatures, I have to do this whole dance of flushing the group head for 10 until the light turns off, waiting 10 seconds until the light turns on, and then after those 10 seconds where the light is on, I then turn on the steam switch for 5 seconds, and then after the steam switch is on for 5 seconds, then I finally pull the shot, as you see me doing right there. So this is a kind of imprecise process to actually hit the temperature I want. So I and other people have had the idea of modifying espresso machines and using electronics to kind of more precisely control what the machine does. And so that's what I'm aiming to do. Here I'm soldering the microcontroller to the PCB, and this is mostly the hardware covered in this video, but all of the code is from the open source Gaduino project. And right here I am splicing together the wires for the sensors, so that's what allows, I believe in this video, I am splicing together the pressure sensor to the wires that connect into the PCB that basically allow the pressure sensor to speak to the kind of brains of the operation. So it's just soldering and then putting some heat shrink tubing over it so that it's insulated. And there were several dozen of these that I did, but I'm just showing a couple to kind of illustrate the process here. And here you can see the entire low voltage assembly. So on the bottom left, that's the thermocouple, the temperature sensor, that's the pressure sensor, that's the solid state relay, that's the screen, and then those are the wires that allow the buttons on the espresso machine to talk to the whole thing, and then that's the microcontroller. So now it's a matter of getting it into the actual espresso machine. So here I'm taking off the lid, and so in order to get the pressure sensor in, I needed to cut the original hose and then splice in a new hose. So I had like a tree connector. And so that end connects to the original pipes and the other connects to the pressure sensor. Now it was a matter of kind of rewiring the high voltage harness. So this was a lot of unplugging, replugging, jumping some cables. And it was more challenging than I thought it was to, physically actually pull these connectors off. But here you can see me connecting the solid state relay to the high voltage wire. So basically this is what allows the low voltage coming from the microcontroller to control the kind of high voltage components like the pump and the boiler. And here I'm removing the boiler. This is what allowed me to get like easier access to stuff like the temperature sensor. This is kind of what the high voltage wiring looks like. And here's the final product. You can now see a pretty accurate temperature readout. And you can set pressure profiles, and basically what that allows you to do is say you want to ramp up to a high pressure, hold that high pressure, and then decrease it gently. And this kind of mimics what you have in a lever machine, except for with a high degree of reproducibility, and you don't have to spend kind of years getting the feel of how to read the pressure coming from the machine, because the computer can just read it for you and do it. And ultimately this is what you end up with. It makes really shockingly good espresso now. Thank you so much.